Good morning and welcome to your science lesson. You need the usual equipment, so pause the video if you haven't got it. You need to have registered on Google Classrooms, so can you head to the stream and answer the question or use the registration document on the classwork tab? And can you make sure that any notes that you make from this lesson are set out as they would be in class? You should have already completed the LSQ. If you haven't, please pause the video and go and do it. When the amount of reactant is more than can react, it's in excess. We use the formula density equals mass over volume. MPV was my favourite, mass equals density times volume. A protein that matches an antigen is the antibody. Antitoxins neutralise harmful toxins produced by pathogens. And the average mass of atoms of an element, including its isotopes, is the relative atomic mass. That's the value that you find on the periodic table and we've been using in calculations recently. Well done if you did get them all right. Remember, we're aiming for at least four out of the 5 right. So today's title it's a required practical title, and it's to determine the densities of different materials. You need to recall and apply the definition for density. Remember, you're not given this in the exam. You need to be able to recall it and apply it. You should be able to use a variety of models to solve problems, make predictions, and develop scientific explanations. So this lesson is about determining the density of different objects. You need to be aware of all the different methods. And I chose this image because it very nicely demonstrated how even liquids can have different densities, how objects, apparently solid objects, can have different densities. And then we also have objects which have, air in the middle. So they would have a different density as well because they're not solid all the way through. All things to be aware of. Calculating the density of an irregular solid, we would measure the mass of the object. So I've deliberately picked a picture of a very oddly shaped stone. It would not be easy for me to calculate the volume of this stone. So we can use the displacement of water to do this. So having measured the mass of the object and recorded that, I then place a volume of water in a measuring cylinder, and the measuring cylinder needs to take the object, and there also needs to be enough water that it will cover the object, but also not be totally lost when I place the object in the water. I need to know that starting volume, so I will write that down. I then carefully, because I don't want to lose any of this volume, I want to carefully slide that rock into the measuring cylinder. And the rock's presence in the measuring cylinder will displace the water, and that will give me a new volume reading. I calculate the difference between the two volumes, and that is the volume of the irregular stone or rock. Using my mass value, those volume readings, I can now calculate the density. Now, I've just said volume readings because in science we like to repeat things. So we would do that 3 times, we would take an average, so that we hopefully get the closest and most accurate density. There's a funny looking metal canister on your PowerPoint. That is a Eureka can. The Eureka can, you would fill up to the base of the spout and you would make sure that the water level is level, so no water is coming down the spout. You'd place a measuring cylinder or a beaker underneath the spout, so as you place the object into the water in the Eureka can, water would be displaced into the measuring cylinder. I can then read that volume. That volume is the volume of the shape I've just placed in the water, that water displacement. Displacement is a lovely word, really scientific, make sure you know it, but that's a really nice way of doing it. The hardest thing is making sure that you've always got a known volume in the Eureka can and that you're not changing that volume or losing water, in which case you wouldn't have an accurate result. Again, you would still repeat it 3 times. Just from the top of your head, I would like you to write down the method for the displacement of water, either into a Eureka can or into the measuring cylinder, so that you know exactly what steps you would take to do this practical. There is a picture there just to remind you if you're going for the Eureka can. Feel free to go back to the previous slide if you want to check what you've written. I'm fairly sure you've done a really good method. Again, take a measuring cylinder, weigh it on a scale. Having weighed it on a scale, record the mass. Place the liquid that you want to know the density of in the measuring cylinder, place it back on the scale, take the mass. Work out the difference between the two masses, and you need to record the volume that you are using. Using those values, you can calculate the density of the liquid. Remember, the greater the density, the more particles there are, the more mass we'd expect it to have. Rather than playing you this video through the Loom video, what I'm going to do is put this link to this video into the Google Classroom page where you found this lesson. You are going to watch that video, please. You are going to use your whiteboard to make notes on the practical and what you see. You get loads of great information on this practical, so take down as much as you can. You don't need to rush. You watched the video, should have taken about 10 minutes. If you paused it, it may have taken a bit longer. You are now going to write up an explanation of the practical from your notes. It's been a funny year. You haven't done any practicals since we came back in September. We didn't do practicals in the previous lockdown, but you should all be able to give me a list of equipment, a sequenced method, which means that you say 1, 2, 3, tell me exactly what to do. And I actually would like you to record any calculations. So I have the formula and I know the values that you used. The video will help you to do that. Have a good look at this slide before you pause it so you know exactly what's expected of you. I would also like you to feel that you can go back and watch the video that you have the link to again and use it to help you write this practical. I'm not expecting you to do it off the top of your head unless you are totally confident. Presentation matters. All the parts should have a subheading. So equipment, underline it with a ruler, give me the equipment list. Method, underline it with a ruler, give me a sequence method, etc. Once you've finished and you're happy with the presentation, you're going to take a photo and you're going to submit it to Google Classrooms, or you're going to send me a copy of the photo. This is really good practice for you. And if you're really not sure what this should look like, you need to drop me an email or contact me through the stream.